We have a few minutes. I tried to start marking more of that first assignment, but kids are exhausting. And hopefully I will get some while I hide down here for a little bit today. I'll wait a minute or two because we're a little bit early. Oh, I thought I heard crying. All right, it's 10:01. We're recording, so if somebody's late or missed out, oh, 7, wow, people showing up, a whole bunch of almost tardies, but that doesn't really matter. That's why we record everything. Yesterday we introduced or reintroduced, I guess technically we defined it a little bit more. In operations, adding and subtracting. Inverses. Troubles. How's this now? Sorry, audio check. That's hopefully that's going to work. So all the stuff that I babbled on about, inverses, opposite operations, blah blah blah. We're going to talk about exponential functions and the inverse of those, which are called logarithms, which people have all sorts of. They make perfect sense, but they're totally different than adding and subtracting. So inverse, we're reflecting across a line y equals x, or interchanging the x and y. We can do it graphically where we drew a line, we pick some points and change the x and y's. We can rearrange. So the function was 2x minus 6. The inverse function is a half x plus 3. And we went through just with a table of values, looking at the graph of Well, something like a parabola. The blue graph is y equals x squared. The red graph is actually 2. The top line is positive the square root of x because it's technically 2 parts because it's not a function, because there's nothing over here, and the square root of 1 is 1. 4 is 2, but it's also the 2 bits. So there's 2 parts to that. We rearranged and looked at how a vertical translation becomes a horizontal translation. Horizontal translation becomes a vertical translation. And then both. And I said, and those are some pictures that were in there. I don't know what that is. Something from Mrs. Legier that apparently is in there. And I said, I'm going to put this up and we're going to go over it today. It's really 2 pages. We'll do this lickety split. Um, because the transformations assignment isn't due until technically Monday, but again, like this Teams tells me, oh, this was passed in 1 day late, this was passed in 2 days late, 3 days late, whatever, I don't care. Um, it as long as it gets done. Um, so what type of reflection is the inverse? In the line y equals x. What do you do to take the inverse of a function? Oh, I don't think I finished a thought there a second ago. There'll be your next assignment, which will have a little bit on inverses and um, radical graphing. Um, I'll wait until like the end of this week or next week to put something up because you have something now. Um, and I don't want to just keep piling on, piling on. I think in hindsight, that transformations one might be a touch long, but that's why we'll wait a little bit. What do you do to take the inverse of a function? Interchange or switch? X and Y. If we talk about it in terms of, oh, that was a bad X. As a mapping rule, X and Y goes to Y and X. So the following tables, create a table for the inverse. Negative 2 and 5 becomes 5 and negative 2. 0 and 3 becomes 3 and 0. 4 and negative 7 becomes negative 7 and 4. A 40-pound 4-year-old makes a lot of noise running around upstairs. Rewrite the equation for each inverse. Be sure to rearrange for y. So our first step would be to say x equals 3y plus 12. Subtract 12. X minus 12 equals 3y. Divide everything, whoops, by 3. Where people make their mistakes with this is not dividing the whole thing by 3. So I'm going to put the y over on the left just because of convention. X over 3 is the same as 1 over 3x. Negative 12 divided by 3 is negative 4. So the inverse of our original function is 1/3 x minus 4. For a parabola, same idea, or a quadratic, any function really, it doesn't matter. It's just we have higher order. We can do these for all sorts of things. So x equals y minus 2 squared plus 5. Move the 5 over. Squared. Square root both sides. That's going to cancel. Plus or minus the square root of x minus 5 equals y plus 2 minus 2. Putting the y to the other side, saying it's the inverse. Y equals plus or minus the square root of x minus 5, all squared, moving the 2 over. I'm going to move that. This part is kind of all together. So it's just an interchange, a switch, as it were. Draw the graph of the inverse of the following function. So we need to know ordered pairs. Well, this is kind of an ugly one. -2 and 3. So why am -2 and 3? So that one's going to map to 3 and -2. This is going to be our vertex. This point here is 0 and 1. So that becomes 1 and 0. These are very -4.8-ish and 0. 0 and -4.8. What's that? -0.4 is going to map to somewhere over here. Da 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 da. 0.4. Oh, down here, sorry. Ish. Well, this one is a bit, because I'm stupid, should go there. Not because that's 0 and -1. And then it's going to be some sort of horrifically drawn parabola. Were I to give you an assignment 1, that would be a little bit. You also can, because we know this is y equals x plus 2 squared plus 3 with a negative. You could rearrange everything because it's reflected initially in the x-axis because it's upside down. This one is the same as that radical function reflected in the y-axis. But that really should just be interchanging points. Determine which of the following sets of graphs are inverses to one another. Justify your reason. My kind of thought on this, I've got blue and red, so I'm going to change this color, is to try to draw that line. Oh, are these reflections? This point is 4 and 0, 0 and 4. Well, that's invariant. Those look kind of good. We'll talk a little bit about invariance. -3 and -5, -5 and 3, those points are paired, those points are paired. I would say that's a yes. Oh, why don't I just clone? Are those two inverses? Well, 0 and -5 go, like, there's no point that's, well, 0 and -3, there's no point that's -3 and 0. 0 and 3, there's no point over here that's 3 and 0. So that one's a no. Those two look to be. What's for fun? Why are people keep texting me? Group messages are one thing until people start bothering you. 0 or 2 and 0, 0 and 2. Oh, that's 5 and 2 and a bit, 2 and a bit, and or 1 and a bit and 5. That one's a yes. 0 or -3 and 2. So that's -3 and 2. This is 2 and 3. Are those inverses? No. For the blue graph to be the inverse of the red, it would have to be 2, and that graph would have to start. I don't know if that looks like it. Down here for that to be an inverse. Again, there's my horrible drawing skills. Like so. So identifying things. Oh, there's more. Oh, look at those two. Those are pretty. We're going to look at those later. Oh, what color do I want to use now? Aqua. So there's our line y equals x, give or take. Those obviously, even though that point is identical, that's just this is actually a it's just a reflection on the y-axis. Now I'm curious. That could be an inverse and a transformation. There's nothing going on there. But that red line and that red line look kind of similar. Not totally identical, but they're pretty close. Oh, orange? Why not? I guess that's not really orange. It looks like y equals x. Give or take there. So assuming the red is our original function, what's going on? Why didn't I get a 0 and 1? 1 and 0. 4 and 2. Or well, technically 2 and 4 goes to 4 and 2. Those are in fact inverses. That is a graph of an exponential function, which we'll talk about in a week or so. That is a graph of a logarithmic function, which we'll talk about some, I guess technically in a week or so is still May, but later on in May. So inverses, there's not really a whole lot to them. If you're able to rearrange and do that, that's what we need to be able to do, especially for the next set of stuff. I don't think there's anything. Oh, that would be all. Quick and dirty today.
Are you gonna put those up? Did you say on the? I can't think, but
Teams, like the fill. I think, or I thought, post files. Yeah, there's a folder in there. I think I put the first section ones. Yeah, I'll put this completed one for number 3 here shortly.
the introduction inverse completed thing.
So well, when I, like, I'll post a blank one first. That's what that first one is. And then the completed one is everything that we would have done yesterday.
And today.
Well, I'll put a new one, like I just export PDF. Like I post them as, like, I just put completed, so that's just me saying these are the notes that has my stuff in them, I guess. Um, and the only thing that I mean, I'm gonna keep. I don't know why I went guard. Um, like I'll keep putting folders for everything. None of you have had issues getting into any of this stuff, I hope. I hope if you have heard or know of someone who has troubles, apparently there's an Android issue that if I put stuff in this class materials folder, um, Android users can't access, but I haven't heard anything um, because I don't use it. Apparently, there's something to do with the permission setting, and it's got to do with editing. But that's why I post things as PDFs. So if you're going to edit a PDF, you got to go through a whole pile of work and assignments. Um, Apparently, I've reviewed 8 of them. I've got 20. So that's if it takes you a little while, um, go for it. Is there any questions? Inverses, I guess, are kind of quick and dirty, and not a whole lot to. I mean, there are other things we can do, which we'll talk about when we do logarithms. We can talk about domains and ranges. But we said if the x and y switch, the domain, I guess I can quickly, let me cancel that. I'm going to put it up eventually. Where, actually, I'm going to do it over here because I like my parabola better. So you did quadratics. This has a domain. Well, it can be, that's what you would formally do. I don't know what Mrs. Parley does in terms of that. The range is the y. It has a minimum, so all of the y values have to be greater than or equal to positive 3. Y is part of the reals. So an inverse, well, algebraically, we switch the x and the y. The inverse has a domain. All of the x values, oh, that was bad. X is greater than 3. X contained in the reals. Well, the y value, if we kept going, that graph would get wider and wider. It can be any y value. Wow, apparently I'm really bad now at making parentheses. And I'll update this one as well. But that's really, as we go on, we'll add a couple. There's one other file, but it's domain and range, and it's the same real thing. So that's all I've got for today. I'm going to try to hide and do a little bit of marking, make sure there's something half decent in all of those. If you guys don't have any questions, we are free to go. And I guess we'll see you on what day? Thursday, right? Because we're taking Wednesdays off now, so we don't do too much. Sound good? I see all sorts of people leaving. You've got, at least it's not snowing today. You're welcome.
Thanks, Mr. McCain.
No problem.